Okay, so we want to look at this question here. Again, this is a modeling sinusoidal functions with phase shift question. So we've got a weight attached to the end of a spring. So it's going dong, dong, dong. It's height t seconds. After t seconds is given by the equation for the following. Okay, h of t equals 5 minus 2 sine of the quantity 2 pi times t plus 1 over 7. So just think of it like this. So where t is the amount of seconds, and then the h is the height. So as the spring bounces, it goes to a minimum height and back up to a maximum height, minimum height, maximum height. And we're asked, when does the weight first reach its maximum height? So what's really helpful here is to, again, use our little sheet, okay? And what we have is the equation, okay? We're going to figure out all this stuff, the intermediary stuff, and then graph it. And the graph, we'll be able to see on the graph when it reaches its height, okay? So with this equation, the first thing I want to do real quick is kind of put it in the form that I'm used to. I don't like having this 5 out here. You know, I like to have my kind of amplitude and my sine out here. And I like to have my midline over here. And I like to have this stuff inside this stuff inside the parentheses kind of factored nicely. Right? So I do exactly that. Now I've got a minus 2 sine. I've got the 2 pi over 7 out front of the t plus 1. And I've got the plus 5 on the end. And I can really just fill in all the stuff that I'm used to filling in now over here. Okay, the equation forms a negative sign. The amplitude's 2. I've got a midline of 5. The phase shift, right, is just the opposite of this. So it's going to be to a phase shift of negative 1. And then the period is going to be 2 pi divided by 2 pi over 7, which is just going to equal 7. Okay, so that I know all the details about the function, or the period I'm looking at. I know all the details about the graph I want to fill in here. Okay, so it's important to remember that the y-axis is height. We get this from the question, and the x-axis, see the y is over here is height, and inside the equation we've got the independent variable t. So I just to help us remember, I put those underneath our graph, because in this situation, the variables actually mean stuff, unlike when in a purely mathematical situation. Okay, I put my negative sign curve shape there, right? I start at the midline, go down, and then go up, right? So this is the point that we're really going to be looking for. We want to know what this point is. That's the first time it's going to hit its its max height. Okay, I just start filling in stuff. So I use the amplitude in the midline to get my height information, or my y information. Now I'm going to do my x information using the phase shift and the period, or I should say my t information here. The phase shift is negative 1, and then the period is 7. So I add 7 to negative 1 to get 6. So my curve is going from negative 1 for t all the way to 6 for t. And now I just want to figure out, ultimately my goal is to figure out this right here, but I'm going to figure out this one first. It's just halfway between. So all I did was I took the first and the last t values on my graph, and I just averaged them to get 2.5. Now to get this value, I just want to average these two. And I get 4.25, because 2.5 plus 6 divided by 2 is 8.5 divided by 2, which gives me 4.25. Okay? And then that, we know that this height point, right, at 4.25 seconds, we achieve a height of 7, I think it's centimeters. Let me see. Actually, that part of the question's not there. So it's some unit for height. It could be centimeters, feet, or whatever. But all we need to do to answer the question is that it reaches its maximum height at 4.25 seconds. I hope that helps.